3 reads, find the area of the largest rectangle, which can be inscribed in a right triangle with legs of length 3 centimeters and 4 centimeters, if two sides of the rectangle lie along the legs. Here's a picture. Here's one side. Here's another side. And then hint, find the equation of the line. Okay, so we have this line here, and this point here is x comma y, this point here is 0 comma 3, and this point here is 4 comma 0. Okay, with 2 points on a line, we can go ahead and find the equation of the line. And also, since we want to find the area of the largest rectangle, we know that what we have to maximize is this area function, x times y. However, we want everything in terms of x. So we have y here that we need to do some substitution. So how do we find that y? Well, we know the equation of the line. So we know the equation of the line is going to be y minus y1 is equal to n x minus x1. And here we'll be able to solve for y. So we can get the equation of this line, we'll have our y value. And then we can go ahead and take the first derivative and find which x and y maximizes the area. And then we'll be done. Okay, so equation of the line, we have 2 points. Let's go ahead and find the slope at 2 points, because we need the slope for this. So, finding the slope. Okay, so let's find the slope. So slope n is equal to y2 minus y1 divided by x2 minus x1. Okay, so y2, let's call this one y2, so 0 here, minus y1, that's going to be 3, and x2 is 4, minus x1, which is 0, so we have that. Therefore, the slope then is minus 3/4. Okay, so we have the slope, and we have a point, so we can find the equation of the line right here. So let's go ahead, y minus y1, let's go ahead and use this point. So this will be our 3 equals n minus 3/4 times x minus x1. That's our x1. So it'll just be x minus 0, that's just x. Okay? And then now let's just go ahead and solve for y. So let's go ahead and add 3 to both sides. So this implies that y is equal to minus 3/4 x plus 3. So that's our y. Good. Now that we have our y, we can go ahead and plug it in here, because we want to maximize the area. So now area is a function of x, and it's x times all this. X plus 3. Okay, so let's go ahead and do the first derivative test. So that means take a prime. So let's go ahead and distribute this first. Let's do some algebra. Let's go ahead and distribute this first. So I distribute the x, I'm going to get minus 3/4 x squared plus 3x. Now let's go ahead and take the first derivative. So a prime x is going to be the derivative. This is a constant. Minus 3/4 a constant, so the derivative of x squared is 2x. So that'll cancel out the 4 here, and you're left with in the bottom here, you're left with the 2. So that's minus 3 divided by 2x plus the derivative of 3x is just 3. Okay, so we have a prime is equal to minus 3/2 x plus 3. Alright, so now we want to go ahead and find our critical points. Let's go ahead and set this equal to 0 then. So we have minus 3/2 x plus 3 equal to 0. Okay, I'm going to go ahead and move this to the other side. So I'll get 3/2x is equal to 3. Okay, multiply both sides by 2. I'll get 3x is equal to 6. When I do that, divide both sides by 3, and I'll get x is equal to 2. Okay, so we have x equal 2. This is our so-called critical number. It's a critical number. By the way, there's also bounds on this. Let's erase here. So bounds. For the x bound, we have, it can be from 0 to 4. So x is in between 0 and 4. And y is in between 0 and 3. Okay? So just noting that there, because this rectangle can be just here or all the way here. And this, the y side can be all the way up here or just there. So x can be between 0 and 4, and y can be between 0 and 3. X is 2 in that case, so we're fine, because 2 is in between 0 and 4. Now, let's go ahead and draw our number line. Break this off. Alright, let's draw our number line. This is a prime x. Let's go ahead and plug in our critical point here. So it'll be 2. And we have the bounds from 0 to 4, so from 0 to 4. So let's pick a test point here. So I'll call this test point 1. And let's pick a test point here and call it 3. And now, plug in your test points into the first derivative. So here's our first derivative. So let's see what a prime of 1 is. So a prime of 1, plug in 1 in here, and we get 3 over 1 minus 3 halves. We know it's a positive number. 3 is greater than 3 halves, so it's positive. So this is equal to a positive number. So positive number, that means this is increasing from the interval from 0 to 2. Okay, let's now look at a prime of the next test point, 3. Okay, so a prime of 3, plug it into here. So what do we get? We get negative 9 divided by 2 plus 3 over 1. Now, negative 9 halves is definitely, well, this is definitely going to be a negative number. Let's look at it right now. It's 2, this is minus 9 plus 6, so we're left with minus 3 over 2. So that's a negative number. So as a negative number, it's decreasing between 2 and 4. So if it's increasing from 0 to 2, and then decreasing from 2 to 4, that means this has to do something like this, and there's got to be a maximum in it. And that's good, because we want to find the largest rectangle by the area of largest, so max. Okay, so at x equals 2, that happens. Alright, that's good. So we know that x equals 2, this area has the largest area. This rectangle has the largest area. Okay, so we want to find that largest area. We only have x, we need y. However, we have this equation here to find y. Okay, so let's find y. So let's do some little erasing here. Erase this equation line. Alright, so finding y. So finding y once we have our x value, well, just plug it right in here, so that y is equal to minus 3 over 4 times 2 plus 3. So this is y is equal to negative 3 halves plus 3 over 1. And that's going to be, let's see, 6 minus 3. So that's going to be 3 halves. Alright, so y will be 3 halves. Okay, so we have y 3 halves and x is 2. Those are the largest or the biggest x and y values that will produce the largest area for this rectangle. Now let's find that area. So erase this over here, and I'll find the area over here. So finding the largest area. Alright, we already have the x and y that produce the largest area, so let's just plug it in. So area is equal to 2 times 3 halves. 2's cancel out. So we're left with 3. Area is going to be 3. And area is going to be centimeters squared. Right? So the largest area then is 3 centimeters squared. Alright.